Arithmetic operates like a language. Just as everyday words have synonyms, different ways to say the same thing, mathematical values can be expressed in different numerical dialects that represent the exact same truth. We use fractions to show equal parts of a whole. In this pizza, 3 selected slices form the numerator over 8 total slices in the denominator. Decimals translate these fractions into a base 10 system, making scientific data easier to calculate. Once you can navigate between these two forms, you have the tools to precisely describe any fragmented piece of the physical world. We simplify this further by using percentages. A percentage is just a fraction with one specific rule. The denominator is permanently locked at 100. The most common point of confusion in this language is the difference between a fraction and a ratio. While a fraction measures a part against its own total whole, a ratio compares two distinct groups to each other. In a classroom of 30 students, 20 are boys. The fraction 20 over 30 shows the boys' share. The denominator represents the total. But the ratio dialect ignores the total. It compares 20 boys directly to 10 girls. This 2-to-1 ratio describes these two separate groups. You use a fraction when you need to see how a part fits into the whole picture, and a ratio when you need to compare one force against another. When multiplication becomes too long to write out repeatedly, we scale up to powers. Exponents allow us to condense massive calculations into a base number and a small superscript. Visualize multiplying x squared times x cubed. Expanding the terms, x squared is 2x's, x cubed is 3. Counting the total string, 1, 2, 3, 4, 5, shows exponents are added, not multiplied, making x to the 5th. Roots act as a rewind button, undoing that work to find the base. Because this notation tracks how many times a number multiplies itself, it gives us the specific shorthand needed to describe values that scale up or down with incredible speed. When numbers become too massive or microscopic for standard decimals, we use scientific notation to eliminate the long strings of zeros. For 1,500,000, the decimal moves 6 spaces left, giving 1.5 times 10 to the 6th. Now try 0.0000045. Pause the video. How many spaces does it move? 6 spaces right, landing behind the 4, giving 4.5 times 10 to the negative 6th. Scientific notation is the standard dialect of global data, used to track everything from the distance between galaxies to the width of a human cell. These concepts stack together. A simple 5% interest rate on a single dollar compounds over time. To track how that money multiplies, we use an exponential growth curve. If that wealth grows to trillions, we shift into scientific notation. Arithmetic problems rarely stay in one dialect. As the scale of a problem changes, it forces us to shift our mathematical language to match. These 7 topics are the prerequisite alphabet for everything that follows. This roadmap shows how these concepts lead directly into higher mathematics. Scan the QR code to download the guide. Mastering these basics is the necessary first step before you move on to the variable equations of algebra and the complex rates of calculus.